Alright, today we're going to have a look at question 24C from the 2018 HSC Engineering Studies. Now this question asks us to use our knowledge of sectional views to have a go at drawing a half section. So the question says an exploded view of an adjustable scaffold foot is shown. And on the next page we have to complete a half section front view of the scaffold foot with the jack nut arm. So when we're doing these questions, we have to try and accumulate all of our knowledge of sectioning. And we have to remember that when we're sectioning an object, we have to either hatch or not hatch certain parts of the object. So importantly, the things that we're not hatching are stuff like nuts and threads and bolts and washers. We're not sectioning those types of objects. We're also not importantly sectioning webs. Webs are part of an object that doesn't span the entire, let's say, depth of the object. So we can see here this web that they've actually called a web doesn't span the whole depth of the object. And if we were to hatch it when we're doing our section, it would imply that this web is the same thickness of the whole object, which we know is not true. So let's actually have a look at what the question is asking of us. We have to, on the next page, complete a half section front view of the scaffold foot with the jack nut arm. The arrow indicates the direction of viewing. Now, as I mentioned in class, this question, the answer is very wrong, and in fact the diagram is wrong as well. So I'd really pray that you weren't the 2018 HSC Engineering Studies class, because in fact this diagram as well does not have the correct dimensions to draw things on. So as we're doing this question, we're going to realize that this diagram does have a few mistakes, and I'm going to show you where those mistakes are, and I'm going to correct them as well. So we're asked to draw a half section, which means that we are cutting this object along a cutting plane. So the cutting plane is actually here because the front view we're looking at here, and we're trying to expose detail on this object. So let's have a go at hatching and drawing the base first. Now if we zoom in here, we can see on the base that we've got these 3 circles or 4 circles here. They have a diameter of 16 millimeters, and this R of 20, what it means is that there is an imaginary circle along here, and it has a radius of 20, which means that this is 20 mils out here, 20 mils out there, 20 mils out there, and that would be 20 mils with that circle there. So let's have a go down at doing the base first. Now, I like to check that the diagram is of the same scale, so we can see that this base is meant to be 110 long. So we have a look here, it's not 110 long, right? This is the problem with this question, is that they're not really, at least the diagram they're given in the question, it's not 110 mils long. Oh, actually, we would expect it would be 55. If it's 110 mils long, we would expect half of it would be 55. But this is not 55, and so many things on this diagram are wrong, and this is a very bad question, but it's the one I printed out for your example. So we're really just going to focus on the skills of sectioning, the skills of half sectioning, as opposed to accurate measurements, at least for this question. So the other thing that's wrong with this question before I start is, let's just do a few calculations here. We can see that this is a 44 diameter nut, right? And we can see it's 154 mils long, this whole arm with nut together, this whole object here. So 154 minus the diameter of the nut, that gets us what? Minus 44, that gets me 110. So that and that together is 110, which means if we divide that by 2, we get 55. So we would expect, and these have to be 55 long. And if we go down here, and we can see that this is what they're drawing, it's not 55 long. In fact, on the solutions, in the HSC solutions, which I have down here, just to show you that this is not the best drawing, In fact, this is in the solutions 55 long. So even in the solutions it's right, but on the question it's wrong. So just take that into account. Often these engineering HSC questions are wrong, and I really hate that it is, but it's just the fact of the matter. So as I'm doing this, I'm not going to really pay attention to these dimensions. I'm just going to draw the diagram and show you how to section, because hatching and not hatching and drawing a good diagram is the skill we're trying to learn today. So we might continue on our diagram. We're going to continue down to show that this object is going down. Obviously, it's a continuous structure. Might make that a bit nicer. Continuing down. Of course, in an exam, we're using the specified pencil. We're not using our iPad, obviously. We're also not drawing in blue like I am. Now, this is a threaded object, and in engineering, the way we indicate threads is through a series, not a series, but two parallel lines. It's how we indicate thread form, is another way of expressing that term, thread form, parallel lines. Now, we don't hatch these parallel lines. I had that question earlier in class. Do we hatch these lines? No, we don't. What we would hatch is we hatch internal threads. If you've got an object that we're sectioning and it's got some sort of hole that's for a bolt that doesn't have the bolt in the picture, then we're not going to section these internal threads. So we are going to section and hatch these internal threads, but we're not hatching external threads. If we're drawing a bolt, we're kind of drawing these threads here. We don't section threads, we don't detail them, we don't hatch them. We just draw parallel lines, and it's understood in engineering what these parallel lines mean. It means thread. So, some more problems with this question is, which is why, again, I'm not focusing on the measurements, is that this nut is 44 in diameter, which would mean it's 22 in radius. So if we have a look here, in fact, this does go out 22, which is correct, but then the rest of the diagram isn't right. So again, I'm not going to focus on measurements. So we can see I'm trying to draw this wing here, and this wing is 12 mils high. So I'm going to go over to my diagram, and I'm going to start drawing this wing 12 mils high. It's also not clear in the question what these lines on the edge are trying to indicate, and I think that's part of the problem with this question, is that these lines are the incorrect length. Again, we're just focusing on the rules of sectioning in this video and in this lesson, rather than specifics on the measurements and how bad some of these HSC answers are. So we're going to go across, across, and then down. I've gone a bit far, which is why, again, advantage of using a pencil. If you've gone too far, is you can rub it out. So I might get a rubber, a fine rubber. What I want to do is precision eraser. There we go, zoom in. Okay, there we go. So now we want to draw this nut on this object. So if I go up, the nut, we're told, is 35 mils high, 35 high. And the thickness of this object is 12, of this arm coming off the nut is 12. So 35 minus 12, 35 minus 12 is 23, divided by 2 is 11.5. So you want to go up to here, and we're going to go up by 11.5 and down by 11.5, 11.5, and then we're going to go across and meet that nut with the center of this bolt here. I'm going to do some rubbing out in a second as well to indicate that this is a nut. And we're doing on the left-hand side the external view. On the right-hand side, we're going to do our kind of internal sectioned view where we're going to do our hatching. Okay, that's nice. Now we're drawing an external view, and of course, if you've got a nut here, right, well, you're not going to be able to see the thread inside. So we're going to have to rub this out here. Again, we don't care about measurements, at least for this question, because it's terrible. But if this was put in front of you in the HSC, of course, we would be fixing these measurements. And I really need to find out what happened in 2018 for these kids, because it's not acceptable in terms of a HSC answer. So we want to draw our webs down here. We go back up to the object. We can see it says that there's web time 4. That's our first web. That's our second web. And we've got our third and fourth web are coming down here. So it doesn't really say that, which is why you really got to look at the question. Web times 4. 1, 2, 3, 4. So let's draw in our 4 webs. We can see the webs are coming off the nut and going down. I'm not going to look at these measurements. We should be able to see it does actually come 16 mils out. 16 mils out. But again, this diagram is terrible that it's not going to work at all. The diagram in the HSC. So we're going to go down. And then we want to go a similar length. We're just going to pretend that this is 16. Rotate my ruler. That looks pretty good. Oh, there. Like that. Okay, that's good enough. Right. Now, if we look up here, on the arm, we've got a circle, right? Now, we don't expose hidden detail when we're doing the exterior view of sectioning, but we might just draw a center line to indicate to the person who's looking at this diagram that this object is symmetrical and the hole on the other side, in fact, is on this side as well. In fact, it should be obvious by now that it wouldn't make sense to half section something that isn't symmetrical. Okay, let's start drawing this on the other side now. It's going to be a lot easier doing this on the other side now because we've got a lot of these dimensions already drawn. Now, we can go a bit further than what we have to go because, of course, we can just rub it out. So we're doing if we've got a pencil, we're doing it nice and light. It looks like about there, but again, nice and light. We can always rub out our lines or make them longer. We're not in any rush, and we're going to do our hatching as well on this side. There's no convention, at least to my knowledge, of what side we hatch on, at least in the HSC, that you'll see them do it on both. A little line there. Right, so you want to draw up. And across. Again, we're not in any rush here. Making sure that everything is neat as possible. Going across. Going down. Going down. Okay, let's see how we're going. Right. Now, when we are sectioning, I've said many times, I hope, in this video that we do not section nuts, bolts, and threads. Now, if I'm cutting this object in half and I'm looking on the inside, if we're cutting this object in half here and looking on the inside, well, then you wouldn't be able to see this part of the nut or that part of the nut. We would say that's hidden detail. If you're cutting here and looking on the inside, you wouldn't see any of this or any of that. So we need to rub that out on our diagram. You would not, if you're inside of an object and you're looking at it, you would not see the nut. So we need to get rid of the nut. Right, that. Couple of reasons. First of all, you wouldn't see it, and since you can't see it, we would say it's hidden detail, and we don't draw hidden detail when we're sectioning. But also, by convention, we don't section nuts, bolts, and threads. That's just engineering convention. Okay, let's go back up to the diagram because there's a lot of other things we have to do. Notice, and remember, we're sectioning here, which means we're looking on the inside of an object and exposing interior detail. See how there's an edge coming up here, and this edge is not going all the way along here, which means the inner part's a bit thinner. We need to make that clear on our diagram. So let's have a go at doing that. We might also take into consideration that there's a circle in the middle, and the circle is coming 25 mils out from the edge, but again, we're not looking at specific measurements in this video. I might just make it even with what I've done on the other side. So on the other side, I've made it 17 from the edge, so I'm going to do the same, 17, 15, 16, 17 from the edge. That's the center of my circle. Okay, I'm going to draw a nice center line to indicate that it's a circle or a circular object that we're showing, or a cylindrical object that we're showing the center of. Drawing a nice chain, which is how we indicate center. Okay. And of course, we're going to have to somehow expose this circle. So to draw those kind of lips, I'm going to call them lips, we need to indicate on our diagram somehow that there is a lip. The lip here. And we're going to connect that to the top. Get rid of that ruler. Connect that to the top. And I'm going to do that on the bottom of the same length. And we can see as well that we go up here, there's also a lip here along the side. So we need to indicate that on our diagram, do some rubbing out. So we go into here, we're going to do a tiny bit of rubbing out here, tiny bit of rubbing out there. We're going to move this up and go like that and like that. Okay, we're almost done. We're going to indicate our circle. So our circle is here. And just check that I'm being uniform again. I'm not looking at specific measurements on the diagram again of just how terrible this question is from the 2018 HSC. Going here. Annoying thing about the HSC answers is so many of them are wrong. You feel like you finally understand a concept and then it's wrong and you just don't know whether you can trust it. So again, just make sure you're asking me or someone to clarify whether you're right or they're wrong, because often they're wrong. We need to draw in our webbing as well, which I haven't done yet. So I might just check from the edge here. I've done my webbing 11. So we're going to do 11 just to be symmetrical. Go 11, 11. Do our webbing. I say webbing, but it's just a web. A webbing, when webbing is not a process, we can't webbing something. Going 11 out. Seems a lot steeper than the other side, but we'll just compare. Yeah, that's definitely wrong. Alright, that will do. Okay, we're almost done. We're just going to see where our hatching is. So the hatching, we only hatch where the object is uniformly the same thickness through, which is only going to be in here, right? So we're not hatching these lip kind of edge things. So let's have a go. Again, there's also a lip along this side. So lip, edge, edge, edge. You can see there's a lip here, a lip up here, and a lip down here. We're assuming that the object is the same on the other side. On the underneath, we're also assuming that this is flipped on the other side. We don't really know. Again, there's a problem with these questions. We can also see a bit up here that yes, it is the same. It is detailing some measurements here. A partial section is where we're just getting a part of an object and drawing it. So yeah, it is the same on the bottom. And that's why my lip has gone up and down. So up here, the lip has gone up and down, and of course on the edges there. Then we're going to hatch. We're not hatching our holes. We don't hatch holes. Again, that would imply that the object is thick there, but no, there's a gap there. Okay, That's our nice hatching. We'll probably do a few more. Right, we're almost done. Now we've got to detail the base. Now again, another thing that was wrong with the HSC answer to this question is that they detailed and hatched both sides of the base, which is wrong. No. So I'm going to go down here. If we do have a look here, we might actually follow the correct measurements here. This is kind of like a fictitious circle, is a one term that engineers do it, a fictitious circle. There's not actually a circle here, but this curved bit here has a radius of 20, which means this is out by 20, and this has a diameter of 16 as indicated over there. So we're going to go out by 20, or 2 centimeters. That's where our circle starts. 2 centimeters right there, and our circle has a radius of 16. Okay, again, if you look at the answers, this is way off because this is such a bad question. Okay, let's do, we're not going to do the same on the other side because we're half sectioning, but if we were full sectioning, of course, it would be the same on the other side because it's a symmetrical object. And we look in the middle, we draw a nice center line. Remembering our conventions of lines. Okay, let's mention measure how far out this is. This is 28, and I'm going to do the same over to here because we are going to indicate that this object is symmetrical by just drawing this line here. Okay, just fix that chain there. And we're going to hatching here. Of course, we're not hatching that circle there, we're sectioning here. And I think that's done. So we can see here also that they've already done that for us. They've hatched to show, right, okay, this is an object that is a certain thickness, and it's the same thickness throughout, so we're going to hatch up there. So that there is the correct solution. Of course, I haven't focused on making this perfect with measurements again because there's so many issues with this question, and in class we're going to actually practice doing these properly, but today we just wanted to have a look at the process of sectioning. So thank you, I hope that makes sense.